The main challenges, particularly in the hot stuff, which is a real area of interest. So thermal growth, I suppose casing schedules, managing potential collapse, the cementing complexity, which Connor's kind of addressed, particularly as we go to deeper wells and hotter wells. Things get a little bit more complicated, and naturally the kind of maintenance aspect as well. So GeoLok seems to offer significant advantages in all these areas.
Welcome to Geothermal Unleashed, where we will explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Valorec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. Today, I'm delighted to welcome two guests that are joining me today from OSI Renewables. First, we have Zander McDougall, who is the Renewables Business Manager, and then we have Connor Lawson, the Principal Engineer at OSI Renewables. So I would like to give you both a warm welcome to the show, and I want to start things off by giving you both the opportunity to introduce yourselves. So Zander, why don't we start with you?
Good morning, and thank you for having us. Nice to meet you properly. My name is Zander McDougall, Renewables Business Manager at OSI Renewables, an oil states enterprise. I've worked in heavy engineering, utilities and oil and gas for 25 odd years, mixture fabrication, asset integrity, manufacturing roles. As I said, mainly oil and gas, drilling and production, and more recently now looking at the kind of new energy sectors, and geothermal probably the most exciting one for me. Lots of the skills, technologies and people are adjacent to the oil and gas industry, so there's a real kind of technology and personnel transfer. So nice to meet you. Thank you.
Yeah, wonderful. Thank you. Okay, Connor.
Yeah, morning. Thanks for having us. Yeah, so I'm Connor Lawson. I am the principal engineer on the GeoLok project for OSI Renewables. I've been in oil and gas now for about 3 years in total. Um, Prior to that, I was in the heavy automotive industry, mining industry, and only recently transitioned into oil and gas. Um, Prior to this, my main focus was on subsea and surface wellhead design, whereas now focusing mainly on renewables.
Very cool. All right, well, why don't we move now? Xander, I'm really curious to learn a little bit about OSI Renewables. Can you share with us a background on OSI?
Yeah, of course. Well, OSI, I think I mentioned it earlier, is a division of Oil States. Focused on delivering or accessing energy together, but kind of corporate speak. But it's a real part of what we do. We want to partner and collaborate to deliver for all energies, predominantly geothermal. For me, um, so yeah, the kind of company itself, lots and lots of experience offshore, onshore, renewables and beyond. This vision embraces a diverse multi-source energy mix that encompasses more sustainable traditional oil and gas, but as well as the low carbon energy stuff. We work alongside our customers who typically are industry leaders and communities, and we look to unlock the potential of today's resources while shaping the future of energy. So OSI Renewables is actually as a result of leveraging our 80 plus years of energy industry experience and the technologies and leveraging the challenges that we've solved in a range of sectors. Personally been working a lot in offshore wind, obviously geothermal, but also looking at the kind of carbon capture storage and deep sea minerals gathering, as well as hydrogen sectors as well. So I suppose the last thing to say is OSI Renewables not only applies field-proven technologies from the oil and gas sector, but also kind of designs, engineers and manufacturers, tests and installs new technologies that supports low carbon energy sources. And those products, some quite exciting products, are award-winning. Our kind of most recent stuff, a couple of awards at OTC for our FDLP, which is an offshore wind, and our Merlin Deep Sea Mineral Riser system as well. So yeah, lots of skills and experience that we think can help drive and enable the geothermal sector.
Very cool. Okay, Connor, can we move now to look at GeoLok? Can you give us a high-level overview of GeoLok and what inspired its development?
Yeah, so GeoLok, we only recently launched GeoLok to our portfolio. We launched it in April of this year at IEDC 85 in Vienna. So what it basically does is, as Zander alluded to, we're leveraging our knowledge we have with any offshore technology. So what we're doing is we're reutilizing the TLP technology, which has been more than proven in the in the offshore industry. So we have numerous years of that being proven. We're reusing that to basically solve the inherent issues that are encountered in conventional high temperature geothermal applications with a kind of traditional geothermal approach. Placement is often kind of inhibited by your thermal profiles and which I get my terminologies correct here, and retarder requirements. Additionally, such wells, what can you see, need to use reverse cementing, which is prone to more voids and relies extensive increased casing weights and greater wall thicknesses to manage the elastic collapse. So in turn, GeoLok decreases our casing requirements and employs a cut and pull approach, which reduces our material costs as a result. Heat loss, cementing voids ultimately lowers the geothermal well downtime and operating expenditures, which is a big thing for the operators.
Great. So one of my favorite things to ask is whenever we're talking about geothermal technology is how it builds on oil and gas technologies. So can you share how GeoLok builds on oil and gas technologies and what makes it uniquely suited for geothermal applications? And I'll direct this question to you, Connor.
Yep. So the biggest one for us, as I said just there, was our TLP technology. So, like I said, that's been used for numerous years. We're now using it in our offshore wind FTLP solution, which is I guess I can transform it. So, what this should do is offer a can't get my words out, transformatable approach to the deep geothermal drilling because the further down we drill, we need to look at different solutions to manage these problems we're going to see. So with the GeoLok, it's going to feature an additive casing and optimization system that accommodates thermal expansion, contraction without imposing additional axial compressive or tensile stresses on the casing string, as we'll see with the lower we go, the more hang-off load we're going to have. So we need to be able to manage that accordingly. So this reduces the dependency we're going to have on having a thicker walled and corrosion-resistant casings and simplifies cementing requirements. This is critical because in traditional geothermal wells, as I've kind of said, typically this is expensive. Like cement, if I'm right in saying there's only one cement on the market in the minute, which is capable of going to the hotter temperatures we're seeing with some requirements for geothermal wells. So if we can, with limitation of GeoLok, it will allow us to reduce the cementing cost, which is huge, especially from CapEx point of view for the operators. So that should hopefully reduce the cost of a geothermal well and lead to a greater return on investment for the operators.
Cool. Okay. So,
Yeah.
Zander, can you talk about what are some of the main challenges in traditional geothermal well construction that GeoLok addresses? And I know Connor's kind of hit on some of those, but maybe you can re-highlight some.
Yeah, I'll touch on them at a higher level and then I'll maybe pass to Connor to do the kind of deeper dive on the technical stuff. But the main challenges, particularly in the hot stuff, which is a real area of interest. So thermal growth, I suppose casing schedules, managing potential collapse, the cementing complexity, which Connor's kind of addressed, particularly as we go to deeper wells and hotter wells, things get a little bit more complicated. And naturally the kind of maintenance aspect as well. So GeoLok seems to offer significant advantages in all these areas. A big one, I suppose, on the maintenance side is being able to monitor and identify issues before they become actually too problematic and potentially shut down the well, which is obviously undesirable. I suppose that touches on kind of cost, well integrity, and thermal performance. Yeah, and they can all negatively impact geothermal wells and potentially inhibit the growth of the sector and the market. So anything we can do to enable the industry is good for us and good for the planet. But I'll pass back over to Connor.
Yeah.
So I'm going to ask I want to ask a probing question to Connor on the technical components. I want to ask about this integrated tensioning system that's a part of the GeoLok. Can you explain how this works and why it's a game changer for well integrity?
Yeah, so I guess the kind of one of the biggest kind of concerns we see is like if we want to reduce the cementing costs under a cool down, there's a potential for basically a casing. So what we're going to do with GeoLok is we're going to basically tension the whole casing, and then we have, as part of our TLP technology, we have our integrated tensioning mechanism, which allows the whole stack to remain in tension the whole time. So then under thermal growth, the system comes into more nominal state, but with our tension system and the components we have within it still keeps tension on the casing string, so it will basically not become unstable, essentially, and we still retain well integrity at this point. So then with any cycling we see of the system, we won't see the casing collapse as you would kind of traditionally see if you didn't cement to surface. Well, as is kind of the norm in geothermal, you have to cement to surface. Whereas with our approach, we want to look more at traditional oil and gas type arrangement where you don't have to cement to surface, and that's why we're introducing our TLP technology into the GeoLok wellhead.
Okay. Okay, so now there is this cut and pull approach that can help reduce material costs and improve operational efficiency. Can you speak a little bit about this?
Yeah. So our cut and pull approach, opposed to, I guess, the traditional section and mill, this decreases the requirements. This decreases the casing requirements. And less casing is needed, lowers the material and operating costs of the geothermal program. This in turn reduces heat loss, which is important because with less heat we can lose to atmosphere or to formation, then the better. So it also then in turn decreases cementing voids, which ultimately will lead to downtime if there's a collapse, and the associated OPEX expenditure associated with that. I guess the conventional approach uses reverse cementing, as I mentioned before, which is again it's more prone to void creation and poor bond quality. So if we can reduce that, great, or not even reduce it, eliminate that, the better. With GeoLok as well, we're also able to lower the stresses placed on the casing to cement bond because we're managing the thermal expansion elsewhere, i.e. because we're pulling tension over the length, we're not going to see that thermal growth pushing against the casing. Pushing against the cement.
So Connor, I've got another question for you. GeoLok maintains an open annulus for continuous monitoring. How does this enhance safety and environmental protection?
Yeah. So with our open annulus, it allows for multiple benefits. These include reduces well downtime, 365 24/7 electronic surveillance to be implemented. Any corrosion products to be quickly detected in it. Allows for real-time threshold and rate of change alarms that may show well health at any time, and allows for immediate shutdowns if necessary. It also allows for better protects shallow aquifers. Get my words out, sorry. And it also reduces the requirement for casing health and monitoring.
Okay. All right. So let's look at potential real-time corrosion detection. So what role does real-time corrosion detection play in protecting shallow aquifers and then ensuring the long-term well health?
So, as we know, the geothermal fluids can contain various dissolved solids that could be harmful to groundwater, especially if released into shallow aquifers. Being alerted to corrosion as quickly as possible will help obviously prevent that, prevent the fluid leaks into the subsequent aquifer. Should allow for prompt detection, enables operators to implement the correct actions they need to do to obviously protect that in the background, and also basically protects groundwater quality, which is essential for shallow geothermal energy systems that utilize groundwater circulation wells, as well as the water re-injected back in the system for a closed loop system.
Okay, cool. So Zander, Can you talk a little bit about how GeoLok contributes to reducing the carbon footprint of geothermal operations?
Yeah, of course. A pretty simple way: less material, less cementing, less work needed. All these things have a pretty significant impact. Obviously, the casing and cement. Reducing casing wall thickness is a potential as well, depending on the well schedule, which will improve the lifetime carbon impact and overall environmental credentials, I suppose. Avoiding the cement to surface, very significant. Aside from the cement saving and the work saving on that, it also allows the cut and pull, which Connor talked about earlier. So the recovery of the materials itself, so potential for recycling, and kind of ties that actually specifically ties into some other oil state services around well repurposing and life extension. So we have Inform and swage lock services, which would allow localized repair potentially, or localized replacement. So you wouldn't necessarily need to fully run or reline. So yeah, those are probably the main areas and how we deliver a kind of carbon energy saving.
Okay, so now let's talk about economics. So Zander, in terms of cost savings, what kind of reductions can operators expect when switching to GeoLok?
Yeah, well, that's the big question. So GeoLok reduces costs through the kind of stuff we talked about before. So reduced casing or casing optimization, simplified cementing, less heat loss to the formation, and decreasing downtime, so better operational performance. As we know in geothermal, one of the challenges right now is the lack of standardization. So I wouldn't like to put an exact number out there, so I'm going to kind of partly dodge the question. But what we can say really is we've done some analysis for a client on the well. The capex savings are significant, but when you add in the operational savings on top of that, including the improved energy recovery, the numbers start to get quite exciting and much more significant. And to any of your listeners, what I would say, any operators or developers more than happy and keen to evaluate on a well basis and kind of demonstrate the business case. So open to inquiries around explaining that in a more private setting, probably.
Okay, so Zander, how does GeoLok impact the scalability and attractiveness of geothermal energy for investors and developers?
Good question. I think the project economics and commercial viability are going to be key drivers in the expansion of any energy technology. So the kind of cost savings and increased commercial benefit of the well, the kind of carbon benefits. There's a kind of strong narrative around all those areas that probably become more attractive. There's a life extension aspect to this as well. We've got some interesting conversations going in even lower temperature stuff where GeoLok technology would seem to offer advantages through life extension and issues with fatigue and corrosion, obviously, through annulus monitoring, etc. So there's a range of areas, probably not the most cohesive answer, but ultimately there's lots of different things that GeoLok delivers on that I think makes the project safer from a kind of investment point of view. Yeah, and extends the life. So there'll be more money generated for longer, which is usually nice for everybody involved.
Okay, so this is my favorite question today for you, Zander. Can you share with us any project that GeoLok is being used on?
So we're quite early right now. We have lots of interesting conversations actually all over the world and all the continents, I think. Some of our parent company, Oil States Energy Services and Geodynamics in the US, have been delivering services in some of the high-profile projects in the US, kind of hot ones, which I'm sure everybody can have a guess of what they may be. So that's a kind of sensible place to start the conversation. We've just completed an NDA with a developer in the US around how do we continue these conversations and where do we go next? So kind of early stage there. We have another interesting inquiry, early conversations with a company called Geothermal Wells in the UK. So that's an early project. So it's not yet funded, but It's the techno-economic assessment phase, but what for us here in the UK, that's a particularly exciting area as well. So the US is leading. They're doing the most exciting and interesting things in geothermal, give or take. But it's nice to see that the UK might eventually follow that kind of path. Also, we've got an inquiry, Cosmos Shoji, our agent in Japan, who are in discussions. The Japanese are also looking at super hot rock systems. So there's a very early inquiry and potential there. And then we have an inquiry as well from the Netherlands, a company called Gaia Energy, who are looking on kind of life extension and managing thermal growth. So there's lots of interest. We're just getting started with this. We invite everyone and anyone that would like to understand more and hear more around that and how we can help them to inquire. But the early stages, but lots of excitement around the product. So does that kind of answer the question?
Yeah, it does. And it's really exciting. Okay. So Zander, what's next for OSI Renewables? Are there other innovations in the pipeline that build on the success of GeoLok?
Yeah, there's lots of exciting stuff going on in a kind of range of sectors. I think from a geothermal first point of view, while we're here, so the wider company has lots and lots to offer. The kind of oil and gas, the land-based services, all states can really help enable the industry. So we know that the growth and ambition within the sector, I think it's my perception that the administration is more supportive as well in the US. So there's lots of potential, lots of energy around globally. And I think from Oil State's point of view, there's a real opportunity to be ambitious and widen a kind of full service offering. I mean, we offer services and manufacture products, OSES, fracking services, downhole tooling, perforation services, completions, interventions, wireline conveyed solutions, which I don't even know what means, but we do offer it. So yeah, probably the next thing would be to see if we can offer a wider package to really enable, make it easier for the developers, operators, and help kick things on.
Great. Okay, so I've got just time for a few more questions, and I want to direct these questions to both of you. So if you could leave our listeners with one key takeaway about the future of geothermal energy, what would it be?
I guess my main takeaway would probably say that geothermal, it's been around for years. And I want to kind of coin on something I heard when I was at IDC, make geothermal great again. It's been there the whole time. It's been there since the Roman times, and it's only now it's reawakening, and it's been, I guess, because the name of the podcast has been re-unleashed, I guess you want to say. And I think with this, it could be used as part of a key part of like a multi-source energy, and not just like in the UK, the US. I think it would be really useful in your remote island communities, especially in the Pacific Ring of Fire, where they have access to super hot rock, and they'll in turn, hopefully, if they implement something like district heating, then it could be used and take a lot of reliance away from fossil fuels like liquid natural gas, which they have to get imported. So to me, that's where I see the future of geothermal being used to help those remote communities more than anything else.
Yeah, very cool. And Zander, what about you?
My key takeaway, I think, is going to be around partnerships and collaboration. We see it in kind of other new energy sectors. The established energy sectors are very powerful, very rich, and deliver lots of value. So I think the only way we compete is to really collaborate and partner. And OSI Renewables sees geothermal playing a bigger and bigger role within the all energy sector. So again, on the theme, access energy together. Let's talk and solve the problems together.
Okay, so my closing question for you, Zander, is where can our audience learn more about GeoLok and OSI Renewables' work in the geothermal space?
LinkedIn, ultimately. If you go to Oil States Industries LinkedIn page, you will get real-time updates of all the exciting stuff that we're doing in the sector. We will be updating our website very soon with all the kind of exciting stuff around geothermal. But right now, hit us up on LinkedIn, and also you can email me directly for any inquiries as well.
Wonderful. And I will be sure to include your email in the notes for this podcast. Well, I want to thank you both for joining me on this episode of Geothermal Unleashed. I hope today's discussion has sparked new insights and deepened everyone's understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.